Hello and salam everyone. My name is Saleh and I'm going to present to you my conference paper titled Image-to-Image Translation Network Using Perceptual Adversarial Loss Function. Let me first introduce myself. My name is Saleh Al-Takruri. I'm a PhD graduate student in Razak Faculty of Technology and Informatics, University of Technology in Malaysia. As well, I'm a lecturer and a supervisor of a college requirement courses in College of Advertising, University of Business and Technology in Saudi Arabia, city of Jeddah. As well, I hold a position as a graduate research assistant in a research operation office, as well in a College of Advertising, University of Business and Technology. So first, I'm going to talk about image-to-image translation. Image-to-image translation based in deep learning model is a subject of importance in the disciplines of computer vision and image processing. A variety of traditional tasks such as an image correlation, image denoising, image impacting are categorized as a typical paired image translation tasks. In computer vision, super resolution regeneration is a particularly important field. Detecting a significant latent space and interpreting feature map of a target image are the key concept of an image-to-image translation task. For example, image-to-image translation have a broad range of uses, creating high-quality images from corresponding distorted images, simplified, corrupted, or low resolution. Translating a color input image into its semantic or graphical representation, like image denoising, image impacting, and image super resolution, which is the case in this paper, as well image correlation and image segmentation. So in super resolution, GANs have recently been utilized to solve super resolution issues in start to end phase by treating the generator as a super resolution model to yield a high resolution image and utilize the discriminator as a binary classifier. SRGAN adds another distributional loss term to output an upsampled image with a resolution increased fourfold based on the DC-GAN architecture. With the residual block ER SGAN introduced to enhance overall perceptual quality of utilized result by presenting the reticel dense block without patch normalization to further upgrade the nature of perceived images. So GAN's generative adversarial network are frequently used to achieve image-to-image translation. Corrupted and low-resolution image can be transferred into higher quality images through application that are based on generative adversarial network. As I mentioned, like in SRGAN, and especially with the appearance of the conditional GAN. Geometric representation can also be drawn from original input of a color image. As we mentioned, image-to-image translation is also applied in various tasks. We are going to focus on this paper in a super resolution task. In recent year, the GANs alternate between identifying data and faking to achieve a training process with the significant adversarial losses. Okay, and that leads us to the losses, the perceptual loss. The most favorable metric that is useful to determining the discrepancy between true image of the ground and generated images in the input is a perceptual loss. Perceptual losses can be suppress undesired feature in the true image and enhance the perceptual quality of an image during image-to-image transformation. Perceptual losses are normally added to generative adversarial discrepancy in a form of a well-trained neural network for image classification. These well-trained neural networks are appended within the generative adversarial network to work with both image generative network and discriminative network. In addition, normally create impressive results but ignore the reality that generative adversarial network need to perceive image content and determine the difference between them. Since perceptual losses are packaged as a pre-trained network with several hidden layers, they make it difficult for the host generative adversarial network to learn about the difference between true images on the ground and generated images. So next I'm going to talk about the CNN model we are going to use in the proposed GAN model. Feature extraction is the most important step for any deep learning model. CNN model has ability to extract feature in one dimension. GAN models use convolutional layer for feature extraction. The problem with this layer is that extract feature in one single dimension. So these GAN models could not be able to find the more fine grained pattern while extracting the feature. The proposed GAN model is a performed compound scaling method while feature extraction, and has the ability to find the more fine grained pattern than the previous proposed network. So in this paper, the convolutional layer going to be we used efficient net, which is a convolutional neural network architecture, and the scaling method that uniformly scale all dimension, depth, width, resolution using a compound coefficient as shown in the figure from the paper. So moving on to the methodology. Of course, previous techniques have found it's useful to combine the objective function of a GAN with convolutional loss function, for instance the L2 distance. For image-to-image translation task, we are presenting the proposed novel approach based on perceptual adversarial loss function P, L perceptual loss, E for efficient net, and finally GAN for generative adversarial network. So for the perceptual adversarial loss function, we used a discriminator network, which is a convolutional network, and manipulate its hidden layer in order to determine the difference between a high-level feature of a transformed image and the corresponding ground truth image. We have used two losses function in our proposed methodology. A transformation loss network to train the transformation network. Secondly, we have the loss of a discriminator network to train the hidden layer of a discriminator convolutional network DN. Both of these layers play a min-max game and form a perceptual loss function that undergoes an adversarial layer training and finally called perceptual adversarial loss. And for the generative adversarial loss function, a transformed TX transformation of an image can be generated by the transformation network granted the input image. The grounded truth images for each given X is available in a form of Y. All corresponding ground truth images will have the same distribution as a given input images. The main task of image transformation network TN is to provide transformed image that should also have the same distribution, of course, of the given input image. On the other hand, the discriminator network makes sure that the transferred network that the image transformation network provide belong to the same distribution as the input image, which is P real. So the generative adversarial loss determines the difference between the distribution of both real and transformed images. So as we saw in the losses, let's go to the network architecture. So the proposed efficient net-based GAN model, PLE GAN, for image-to-image translation is composed of two distinct networks, as we saw previously in the slide: the transformation network and the discriminator network. So for the first network, the transformation network for image transformation is built to create the transformed image from a given input image. The transformation network first encodes the given image, adopting the network model of using a set of a hidden layer into a higher dimensional representation. The model then decodes the encoded image into output image using a stack of a hidden layer. The transformation network uses scaling method that uniformly scale the dimension of an image while extracting the feature into resolution, depth, and width following the efficient net model, CNN model, using a simple yet highly effective compound coefficient. This is a highly effective approach while convolution and deconvolution in order to encode and decode the image. The transformation network uses a stack of 12 convolutional and deconvolutional batch norm leaky ReLU layers. Expect the last output layer use a tan H activation function. And for the discriminator network, the second network, it's contain 8 hidden layers, out of which one convolutional, 6 RMB conv of a building blocks of an efficient nets convolutional layer. Expect the last layer, which is a flattened layer. A sigmoid function is employed at the end of the network, which is determine the probability of an output image, whether it's real image or fake image. Both the discriminator and transformation network trained alternatively in order to undergo adversarial training of a loss function. In figure 1, as you can see, the proposed efficient net-based GAN model, PLE GAN. As you can see, we have here the transformation network to transform an image. It's a new net shape for transforming an image, and we have the CNNs of the efficient net here. And after, of course, the image transformed gonna be compared to the ground truth image to calculate the probability by a sigmoid function at the end. And we have as well here the discriminator. So this is the transformation network, and this is the discriminator network. And of course, we have losses hidden in the discriminator network through the whole training. And we did we experiment our proposed model using we did our experiment and testing in a Google Colab platform for 100 approximately images, and we use these different data sets. For more information about the data sets in the paper, in the manuscript. And PLE GAN, the proposed one, comparing to the other algorithms, shows a really promising results, and the running time of the training was a fair good. And here an example of the proposed model PLE GAN. You can see it's It's has more features, has more higher features here comparing to the other algorithm like in SR GAN. This is in dataset 5. So in conclusion, unlike the traditional GAN-based model for image-to-image translation task, in our case it's super resolution, the proposed PL-GAN employ both the generative loss and the perceptual loss as an object of the function to the network. PLE-GAN loss function undergoes adversarial training and serves to detect and decrease the difference between given input and transferred image. It is expected that the proposed PLE-GAN based approach can add value to the current image-to-image translation in super resolution domain. And thank you so much for listening. And if you have any question, please do ask. Thank you so much.